Hi everybody, welcome to my first video. I'm actually recording this intro after I recorded the rest of the video footage, just because this was supposed to be like a fairly simple repair, and about halfway through it I went and got a booster shot for you know what, and I ended up feeling like total crap for the rest of the video, so my voice wasn't the best, still isn't the best, and I feel like the video quality suffered a little bit. So, and also I was only able to splice in like just a very small clip of microscope footage, mostly because I'm still running into some issues with my setup, still trying to figure all that out. But I will get a better microscope camera and figure out a better way to capture that, and hopefully, or actually I'm sure my next videos are going to be much better quality. So without further ado, enjoy the video. Thanks, bye. Okay, hello everybody. So I got a couple of customer boards here, 3 S17 Plus boards. The story of the customer is that he bought a unit from a Chinese supplier. When he received it, he's in Canada as well, and when he received it, a couple of heatsinks have fallen off, which is not a big surprise, but he did have one board that was working. I got it hashing for a couple of days, I think, and then that board also stopped. So when I received the box with the hashboards in it, two of the hashboards had 2 heatsinks missing, and one of them, the heatsink actually fell off while it was still in the packaging, and the chip is completely removed from it. So I'll show you that when we get to that board. So first, look at this specific board. So we're just going to give it a quick visual. So right off the bat, I can say a couple of things with the heat sinks, right? So we can see this one heatsink here is kind of crooked compared to the other ones, as well as this one that's obviously very crooked. So either this board was reworked before, which is very possible. When I said this one also is a little bit misaligned. So either that board was reworked before, or got so hot that, for example, that heatsink just slid off and ended up resting in that final position. So everything else seems to be fine from like a quick visual, both in the front and the back. Okay, so I'm gonna look at that under the scope. Alright, so quick scope going. So here's one of the chip that is missing its heatsink. And as you can tell, the heatsink took quite a big chunk out of the core of the chip. This is pretty deep. Okay, moving on to the next one. Again, this is also pretty deep, so it's got a lot of material missing from the chips, but there's a chance it might still work. Of course, we have like nothing to put the heatsink back on, so we're gonna have to replace those chips regardless. And I'm also gonna have a look a little bit closer to that heatsink that's really crooked. And I just want to make sure that it doesn't actually touch the heatsink next to it. So, which it doesn't, which is good, because of course you don't want any core short circuit between those two domains. So what I'm gonna do, we're just gonna throw that on the tester and see what happens. So I'm using the Russian tester, but any tester works obviously. So I got 21 volts on my bench power supply. So it's always data cable negative and positive, right? So I'm gonna make sure we get that right. And then I'm just gonna start the tester and see where that says. I don't really need to go into the web interface. So 65, which is pretty good. So, well, it's all of them actually, so it's really good. So this board, you know, the customer did the right thing by not trying to run it, obviously, without any heat sinks. But the board, the chips are actually working. It's just we still need to replace them because we don't have anything to put the heat sinks back on, unfortunately. So yeah, so that's going to be a double chip replacement. I'm not actually going to show that on video right now because there's a lot of subtleties that go into it, and I want to do that justice and make sure that gets its own video in a near future. So I'll do that on that board off camera, and we'll be back. Next board. So this is the board that was initially hashing, and that failed after a couple of days. And I'm trying to find the heatsink that came off of it. I don't have it on my bench right now, but as you can see, or maybe you can't see, but the chip is completely missing from this area right here. So it actually stayed on the heatsink, which is a little bit worrying. That tells me that maybe that board ran hot enough to melt the solder. And if we go again back to the scope, there we go. So as you can see, completely missing. And those, I don't know what I think of those solder. I'm not sure if that's a factory job or not, and I'm not sure what's going on in this corner right here. So that's, no, I think that was reworked before, because that's flux. That's like really old flux. That's really kind of crusty. Interesting. Maybe it is. Maybe it is not. I don't know. Regardless, yeah, it doesn't matter. We gotta fix it regardless, right? So that's one thing. And then for the rest of the visual inspection on this, so the heat sinks do look good. Oh, except for that one, I guess, the one like right next to the missing spot. You can tell it's shifted also a lot towards the next domain over, so there's almost no gap here between those two. And that's a problem. So I'm not going to be able to power on that board right now. I'm going to have to remove this heatsink to make sure it doesn't touch the next domain over and go from there. Other than that, visually, looks pretty good. Nothing else really to report on that one. Yeah, so let's go ahead and remove that heatsink and go from there. Oh, should have changed. There we go. So I just put a bigger end on my air wand. So when I try to do that, I try to shoot it directly from the top. And I just gently move it. There we go. Turn that off. Alright, let's have a look with the scope at what this looks like. Sorry, the exposure is all over the place. So lots of solder balls on that one, and also very dirty. I'm just gonna try to clean that up real quick. So this one, yeah, there we go. And this guy, oops, there we go. Of course you don't want to drop it on the PCB somewhere, because then it's just going to be another problem down the road. Alright. So is it me or is this crooked? So again, there's a lot of old residue here, which could be from working on the next chip over that we just looked at earlier. I'm going to try to clean the edge of this chip. It can be fairly aggressive here because there's no pin on that side of the chip, obviously. If I were to scrape the sides, like, it might be tempting to scrape this one side, but you want to be like really gentle and really just glide on top of the pins because you don't want to rip the solder that's on there. So I was looking for that stencil mark right here at the bottom, the white line, and it seems to be even with the chip all along the side of the chip, so it doesn't look like it's actually crooked. So let's give that a quick cleaning. And that's gonna help to see things. Sorry, I just noticed that. Okay, so I just turned on turned it up the light. It's kind of annoying what it does there in the software, but anyway, better solution coming. Okay, so yeah, overall not too bad. I'm just gonna finish cleaning up this corner right here, which is good. Okay, so that looks good. But if we look again, this is the one where the chip got ripped. So we're definitely gonna have to put a chip on there. And now that we remove this other heatsink, then we can go ahead and power it up. So of course we're only gonna have 65 because we literally have a whole chip missing of the board. So it's impossible for that last domain to even communicate. So again, when I connect the board, it's data cable, ground, and positive, right? We can start that for shits and giggles. 0 as expected. And then we are going to, let's go back to the scope. We are going to take our jumper and do that 1.8 volt inject technique, which I will have a video on at some point. So we know that this domain up here is the last one, so it's going up towards the right of the screen right now, and this is the second to last domain, which is going to the left of the screen right now, so this way. So if I want to try all the chips including that one, then I can short after this one chip, which means I'm going to take the 1.8, which is here, which is pin 17, right? 16 here and 17 here are both supposed to be 1.8. And then I'm going to short that to RO, which I know is the center test point right here. And then you can't see the tester, or maybe you can. No, you can right now, but it just changed to 59. So, and this just happens to be chip 59 right here. So we know that the chain up to here is good. Let's see if I can get that in focus. I can't really because it's trying to focus on. Okay, so you see right now it says 0, right? And then I'm just gonna get in your shot for a second while I reposition. And then if you watch the tester, 55, 59, there you go. So, so we know that the chain is good up to this. And then, excuse me. And then in order to test this next chip over, I would need voltage from the next domain over. But because we're missing a chip as part of the last domain, then that 1.8 volt does not propagate. Actually, it's not true. I can use the 1.8. Let's go back to the scope. Sorry for the squeaking. Alright, so I know, so because the 1.8 usually goes, so it starts here, right? And this bottom capacitor goes into this trace, goes to the pin 17 through the chips, comes out on pin 16 and makes its way back to the next chip over. So because it's missing a chip, then we won't have any 1.8 on this side, but we will have it in theory on this side. So I'm going to take it from this capacitor with my black probe and just short this guy right here. And no change on the tester. So either I don't have, so make sure I got a good contact here. Nope, still nothing. So either I don't have 1.8 volt there, or we got another bad chip between this one that we tested good and this one. So let me just poke this right here to this heatsink. I got 1.8. as expected. So let's redo that test again and make sure I got a really good contact. So I'm just going to put a little bit more pressure in here and to this middle test point. Nope, still nothing. Alright, so that, anyway, that tells us maybe we're going to have a little bit more work to do. Let me just stop the test here. So as a recap with that, what we did so far. So we tested up to this chip. That was 59, so we had 59 good chips. So we know the chain, we know that all those chips are good up to here. And when we tested these two chips by shorting 1.8 volt from the last domain up to after this chip, then we had 0. So that means that either this chip or this chip has something going on there. So I need to remove this heatsink anyway to access to install a chip here. That's going to be the easiest way. So we're going to have a look at that, and I might as well take this one off at the same time. Actually, I'm going to do that right now. So I don't like working on a board that's connected, so and these are the bigger heat sinks, obviously, so they do require a little bit more time to heat up. And might as well get that one as well. Alright, let's see what we got. So these are, get a pointing device. So this is 6061. I mean, I see still a lot of solder balls, which is not good. That's just problems waiting to happen. But yeah, nothing really significant happening on those. I'm just going to give them a quick clean. Especially that side where, yeah, so that's the dirty side. So whenever the fans push the air through the miner, then it goes towards the left of the screen right now. So that's why you always have one side that's really a lot dirtier than the other one. Oh, I think I saw a solder ball there, but I think I got it with, oh no, there it is. Tiny long guy, I think. Just gonna finish cleaning that up. Yeah, so nothing wrong visually with any of those two. Looks good. Alright, so I'm just gonna repeat that test that we're doing to test the chain. And so, yeah, so again, we know that this one is good. There's no chip there, obviously, so that's not good, but we were not able to get the status on any of those two, either 59 or 60 or 61. So let's split the difference, test ride between the two, and see where this goes. So I'm gonna turn our tester on. I'm gonna again take the 1.8 volt from the last domain and just put it in the third touch point there, which is RO. And if I get good contact, you'll see that the tester is now showing, oh sorry, let me just get it back on there, like so. So you see now the tester is showing 60, which means that, so we knew 59 was good, now we know 60 is good. 61 we can't get a reading on, but actually we can because we don't have the 0.8 volts either. Oh, do we? No, we don't. So yeah, so that's normal. So chances are that one is also good, and we're only missing chip to get a whole domain going. So that's going to be a chip install there again, which I'm going to do at the same time as the chip replacement on the other board. All right, let's move on to board number 3. Okay, so board number 3, visually very similar to our board number 1. So two heat sinks missing that were ripped off during shipping. This one actually not as bad. You can tell there's a lot of some good solder balls there, but there's a lot of or actually the heatsink didn't rip off any. Oh, that's on there. Yeah, it didn't rip off any material of the chip itself, which is good. So usually if there was like any copper left, then we could just put it back on and hopefully be good to go. We're going to test them in a second. But so I see this chip is actually missing a chunk, like a whole corner, and you can see like very much the inside of the chip. So anyway, we'll see what that chip says. But as my okay, but yeah, just so we're gonna have to replace it anyway because we don't have any copper to put the heatsink back on. So visually looks good. There's still some little misalignment here, like somebody's been in there or maybe it got hot and shifted, so something to keep in mind. And on the back here, yeah, that looks good. Everything seems to be in place, so there's nothing that would prevent me from putting power to this board right now, so that's what we're gonna do. So again, we got data cable, ground, positive, and let's fire this up and see what happens. 65, so we got all of them, and as expected, just like with the first hashboard we did. So everything's fine, just that we don't have enough copper on the chips to put the heat sinks back on. So yeah, so this is going to be another 2-chip replacement. Yeah, so in summary, so we had our first hashboard, all the chips were working, 2 chips that did not have enough copper to put the heat sinks back on, so those are going to need to be replaced. Number 2 needs 1 chip put back on there to have the whole domain complete, and there's going to be further testing obviously, but we should be good. And this board number 3, same as board number 1, needs those 2 chips replaced so we can have copper to put on the heatsink. So yeah, so I'm going to do that and I'll be right back, see what happens. Alright, and we are back. As you can tell, this is board number 1 still. Still get that crooked heatsink that I did not fix. But you also notice that there's a couple more heatsinks missing, and here's what happened. So that S17 Plus board threw us for a loop, as they do typically. What happened, so you'll see I switched swapped those 2 chips for new ones. And when I swap a chip, the first thing I do, I check the resistance between the ground of that domain and the 1.8 volt, feeding all the chips, expecting like right around 1.2K. That seems to be the norm. Usually, let's say between 1K and 1.4, let's say on average. That one had something like 120 ohms, so 120 instead of 1,200. So way too low in my opinion. So I chased that for a while. And if we moved on to scope cam, and if I hit record, you'll see I chased that to this one cap right there. That was mostly shorted, so not quite, but very, very close. And so, of course, that's not a good thing, because then if your 1.8 volt comes from upstream, let's say from this right side where the LDO is, through all the chips going right to left right now, if there's a short here, then the current going through all the upstream chips is greater than it should be, and there's a risk, of course, of burning those chips. So so I plugged in a tester after that, which I will redo right now. So again, we got data cable, negative, and positive, and I just noticed that my tester isn't actually powered up right now, so bear with me, I'll be right back. Just like a minute for this guy to boot up, and I'll be right back. Okay, so here we are, this guy powered up. I didn't hit the button yet, but I will right now and see what happens. So as you can see, 27 chips. So we lost some chips. We went from having all 65 with 2 chips that we knew had to be replaced because of the heat sinks to now 27 chips. So 27 chips. If we look at it, so this is your chip number 1, bottom left here, so that's 5, 10, 15, 20, 25, and then coming around 26, 27. So let's have a look at in that area. Scope cam again, make sure that's recording, yep, okay. Alright, where are we? So that's the start of the domain. As you can see, the traces are going around here. That's 26, and that's 27. So let's have a look at the next one in line, 28. Doesn't look the greatest, as you can see. Looks like it got hot a little bit, and I already picked some pieces, but I was able to pick this whole chunk of solder here that really wasn't stuck on the core anymore. See, there's another little part here that's coming out, and so like you should be able to peel off the solder right that obviously. So that tells me that this probably got hot. Or you know, some sort of internal short that made it overheat, most likely because of that shorted cap that that I found further down on the domain. So unfortunately, I think we got a 3rd chip to replace. The next step now is obviously to check the signals, make sure that everything's good on that one, and go from there. So what I'm gonna do, so you can see the test points on both sides. I'm gonna put the meter voltage mode, and I know my meter is off screen for you guys, but I will call the numbers for you. Start the test on my tester. So if I look from the top of the chip, this would be clock. Right now I got 0.87, which is alright. Over here we got 0, so that is not good. This is CI, I believe, 1.8, that's good. Let me get in there, 1.8, that's good. RO doesn't really mean anything right now, but it's actually 0 here, which is suspicious. This is BI, I believe. Let me double check. No, that's reset actually. So reset, 1.8, that's good. So that means the chips are turned on, 1.8. And then BO is 0 here and 0 there. So we got 2 anomalies. We got a good clock coming in. We got no clock going out. And we do not have an RO coming in, which we should be. So let's have a look. This is one of the chips that we replaced. Let's have a look at the RO over here relative to this next domain. 1.4 doesn't look too good, but maybe if we have a look here, 0 again, and this guy has 0. So there's a little bit more work to do, more troubleshooting. I'll do that and come back on camera and see where that goes. Okay, so did some more thinking on that, and I actually suspect this bottom chip. This is the first one along in the chain that I replaced. I suspect that one to maybe be DOA, dead on arrival. So I still have my flux on there from when I installed it. So I'm just gonna clean it up so I can judge better the quality of my solder job. If we zoom in real good, I mean, I think it's an acceptable solder job. It's not my best work, but there's nothing here really that would suggest that the chip is not where it's supposed to be, or that it needs to be reinstalled a second time to be lined up properly. So alright, so what I'm going to do right now, I'm going to pull it off and try another chip. Okay, and we are back. If that camera can stop shaking. We are back with this board, first board of those three S17 Plus boards. As you can see, things have escalated a little bit. Initially, we thought it'd be just 2 chip replacement of that board. And right now I got all the heat sinks taken off of that domain. So when I replaced the 2 chips that needed replacing, we went backwards as far as number of chips, and the chip next to it right here, which is the third in that domain, so that would be chip 28, decided to stop functioning. So that board threw us a curveball, as they do typically. Troubleshot a power problem, found a shorted cap, which probably contributed to some of those chips being in less than stellar condition. So I did replace chip number 28, only to find out that one of the chip that I had put in wasn't passing clock, so I had to reinstall another chip on that one. So that one was dead on arrival as far as my chips go, unfortunately. But so basically still got 3 chips replaced for the customer, and if we fire up the test right now, you will see that excuse me, 65 chips, so we are good to go. So next step is, of course, to put the heat sinks back on, and I'm actually gonna take this guy off and make sure everything's good underneath there. Actually, we can do that right now. Don't like to work on a board that's powered up. Alright, here we go. So I heat the heat sink sideways. I aim right in the fins. Excuse me, I'm a little under the weather today. And as soon as that heat sinks starts to move, there we go. You can have a look underneath. Everything looks good. Okay, so here we are trying to put this heat sink back on now, because that's the next step. So what I like to do, I'm gonna have a look at how much solder is on there. There's a decent bit, but could use a little bit more maybe. I'll try it like this. So what I do is I preheat the heatsink for maybe, this is a big one, so maybe like 15-20 seconds, not a whole lot, just to save some time. And then what I do, get it in there, line it up, make sure I get a big of a gap for my test points. And I'm going to heat the heat sink from the side as I wiggle it and try to feel it sit flush on the chip. And of course what it does is going to mean that all the solder is melted. There we go. Pull the air off, blow on it a couple times. Release pressure slowly, and we got a heatsink. And what I like to do, just to make sure that it's on there, I just take my small needle nose. You put them on the that middle part, that wider fin, if you will, and just wiggle it back and forth a couple times. And then if it's on there, then it's on there, right? So you want to find out that it's loose now, as opposed to when it's a machine and then it falls off and short circuits a bunch of stuff and causes a lot more damage. So if it's loose, you want to know now. Also, another thing that's a very good idea to do on these S17 Plus boards is to test after each heatsink that you put. So, as we know, those boards are pretty picky, pretty sensitive to heat, and so you'll see, go back here. So yeah, so still got 65, no worries. So that one's good. If you don't have 65 after putting on a heatsink, a couple things that could have happened. Maybe you got some solder that made it from the bottom of the heatsink onto the pins, shorting out some pins. So usually you have like a partial count of ASICs at that point, or that chip is just too hot and is not replying or is not doing its job. So the tester doesn't see it. And if that's the case, just let it cool down a bit, test it again, and see what happens. So, all right. That's it for now. I'm gonna put the other ones on time lapse and testing them in between, and we'll be right back. Okay, we are back. So as you can see, I've put all the heat sinks back on. There's this road here. Everything should be good. So I'm gonna test it on the bench one more time. Hopefully get 65. Yeah, there we go. So all the chips are detected. So now we're gonna go throw that in the miner and see what happens. Okay, and we are back, board number 2. I think this was board number 2. Same as the previous one. 2 chips that don't have enough copper left to put a heatsink on. So we're gonna go ahead and replace the first chip, test it, make sure everything's good, then go ahead and replace the second chip, test it again, and hopefully this one is gonna be straightforward like that. Alright, I'll do that and we'll be right back. Alright, we are back. I don't know if you can tell, but this chip has been replaced. Now it's got some nice solder on it to put the heatsink back on. And although the board is a little warm right now, I'm gonna test it anyway. And I still got my 65, so that's good. So yeah, again, with those S17 Plus boards, you want to test often between like each action you're doing. You want to test it so that you know if you're heading in the right direction, because we know S17 Plus boards can throw you a lot of curveballs. So I'm going to go ahead and replace that other one, and we'll be back. Okay, it's actually the next day. I am still sick, you can probably hear it in my voice, but went ahead and replaced that second chip, and now I'm going to see if we still have 65 ASICs. Yep, we do, so should be good to go. I'm going to put those 2 heatsinks back on and go from there. Okay, let's see if we still have our 65. And it appears that we do. Alright, so that's board number 2. Probably fixed. Just throw that in the miner and make sure it hashes. Okay, we are back. As you can tell, I got this heatsink on the workbench. And I got the last hashboard from the customer. If you recall, this heatsink fell off and the chip actually stayed stuck to the heatsink. I don't know if you can tell on the camera. Not quite, I don't think so. Yeah, there you go. So there's some like solder balls right there that stayed, well, that were there in the first place. So anyway, it looks like that chip was reworked at some time in the past, and maybe the person that did it didn't do the best job of, maybe it wasn't hot enough to do a proper melt on the solder or whatever. Anyway, so that board the customer had actually working for a couple days, and then suddenly it stopped. So that is what I found. So what I'm gonna do, I'm gonna try to reuse that chip, because there's no point wasting money on a new chip if that one's still working. So whether it is working or not, I guess we'll find out. So what I'm gonna do, first of all, is try to get that chip out of there and hopefully put it on the board. Might have to redo some of the soldering on this. Alright, let's go. Okay, so I went ahead and put the chip back on there, as you can see. And good news is that chip still seems to be working. Still got 65 ASICs, so I'm gonna clean up my flux. Clean up after myself, because that's what you need to do, and then I'm gonna put those heat sinks back on, and should be good to go. And welcome back. So I want to apologize, I didn't get that last part on camera. But basically, I let the board cool down and everything is fine now, as you can tell. You're gonna see 65, there you go. So I think that's it for the repair. The other 2 boards I have from this customer are currently hashing at about 50 terahash a second combined. So that's right where they're supposed to be in this S17 Plus. I think that's a 76 terahash version. So I'm gonna go add this one, and hopefully I'm gonna get a full 75, 76 terahash, and everything's gonna be good to go. Okay, thanks. Okay, a bit of a follow-up. As you can see, we are back on the bench. This is the 3rd board that I'd work on, the one that had the chip completely missing in this area right here. So what happened, we had all the chips detected at the end of our video. Threw it in the miner and it mined for about 3 hours, and then the board dropped again and could only detect 60 ASICs on the board. So I brought it back on the bench, took out those 2 heat sinks, 60, 61. Didn't really find anything significant, so ran the test, and when I probed around, I found out that number 60 was not actually passing the CI signal. So CI is supposed to be around 1.8 with the test running, and I think that one was around 0.7, maybe, something like that. And so that's a good example where a lot of people, when they would come across a case like that, where you have a certain number of ASICs detected, they would always try to go for the next one. So in this case, showing 60 ASICs, people would try to replace maybe number 61. But in this case, even though 60 was able to reply to the tester and the control board, it wasn't passing on the signal for 61 to do its thing. So
So in this case, I replaced number 60, and I actually finished putting together a new computer in the meantime, so I will be able to insert some better microscope footage right here. And so now if we look at the tester, it says a solid 65 almost instantaneously, so that's good. So I'm gonna put the heatsinks back on again and throw it back in the miner. Okay, bye.